Hello everyone, and welcome to IMSC 685 MIS. Today we're going to continue the K nearest neighbors algorithm in Python. Before the class begins, I want to make you aware of a new announcement. This new announcement is by our provost about the A, pass, and fail options in your for your grade. And please read the announcement, and there's a link directly to the provost announcement and to see all the detail. I just want to remind you this is happening as a great option for you. And to start with today's lecture, we're going to ask you to go to the course module and go to basic machine learning course module. Download the fourth notebook, K nearest neighbors, using breast cancer dataset, and the dataset will be the last one for now on the course module, breast-cancer.csv file. So let's start with this module. And I start with a new Jupyter notebook to begin with. All right, but before I begin, I type in the library we need to import. Pandas, a Seaborn library for plotting, as well as the matplotlib, .pyplot, and also we need to import the NumPy since we're using Jupyter notebook, so all the matplotlib will be inline display within the notebook. For getting the data set, here I illustrate three different methods to how you can get your breast cancer data set. This breast cancer data set is from Wisconsin, and it's about 570 total cases, how to diagnose a patient who has a breast cancer or not. Let's first import and reading the data set. I'm using the third option, which is the CSV file I have uploaded. Let's take a look at this is the data set we have. Initially, we have the patient ID, and the second column will be and the second columns represent the diagnosis is either malignant, or benign, and each one of them. And so also various of medical image measurements on the X-ray. So let's take a look at about the information available. So total 569 data set, for actually 30 different feature. The first one is patient ID, the second one is the outcome, which is the diagnosis, and we have about 30 other features. However, we notice the last features we have in this data set is has all zero, no value. We need to drop this since we don't need those. So here we have the drop, which is M32, and x6 equals to 1, and in place equal to true in that case. So we're dropping the last one, and okay, and also we want to make the patient ID to become the index. We're now going to use that to fit the KNN algorithm. So let's do that as well. Set index to actually using ID column, okay, and in place, equal to true. Okay, let's take a look again, the data set. Now the data set is using the patient ID as a index, and the first column will be the column 0 will be the diagnosis, and the rest of the columns are the features we want to train our K nearest neighborhood algorithm with. And the next we're going to, since they come in with a different range of the numbers, since these are all number, the most important step for machine learning, we need to standardize our data into a similar magnitude of information. Otherwise, the larger data, magnitude data, tends to have a bigger influence on your we call it distance matrix, or distance calculation. So for example, this area worst and some of the information, and here is the area average of the area of the tumors. So these type of things tend to have a larger impact on your classification, distance calculation. So we want to so-called normalize all the data we have into the similar range. So what we do, we're going to import. Let's do a little bit move up. So let's do from the sklearn, okay, dot preprocessing portion of an import so-called standard scalar. Okay, standard scalar. Oops. All right, and after we import that, I'm going to define a scalar, okay, as the standard scalar we have. Okay, so define the standard scalar. What we need to do is we need to scale all the data except the first column, which is the diagnosis information. So, okay, sorry. Okay. So, after it's done, we're going to start fit the scalar, trying to calculate the scalar. Dot fit, basically. So we're going to do the fitting, which is scale all the data, and using the data frame we have, but drop only the diagnosis information, part of the information. We're going to drop that column and scale the rest of them. And we're going to x minus 1, x is equal to 1. So make sure it's column information. Okay, and to drop the diagnosis column and using it for fit. Then I'm going to transform all the data using this fit. So the fit portion is just figure out the maximum and minimum value in the column and divided those by the range. And so what we're going to do is now since we figured out the range for each column, then we can start to transform all the data into relatively scale. So here again, I'm going to do a scalar. The transform, okay, the data into the similar, the EF, drop, and here is drop the diagnosis column and put in axis equal to 1, transform that, okay. Then I'm going to save the transform issue into a so-called scale the feature, because these are the portion we have after the transform, and we will save it into a data frame called scale the feature. Not a data frame, actually. This is a numpy array. So this will be a numpy array instead of a panda data frame. But we need to later on transfer it back to a panda data frame. So here I have the feature, okay, data frame feature. We're going to transfer this back into data frame, panda data frame. And I will have scale features, and I'm going to call column, drop the first column, okay, for that. Column. Okay. Okay, columns going to drop. So let's take a look at this new data frame now. Probably first 10 of them. And you can see that they start with these are all features right now, okay, and for everything we have, the next one we're going to do is we start as a standard procedure. We're going to split out the feature into a training set and and the test set. So again, we're going to import sklearn, the model selection, calculate import, trend test split. Okay. Okay, for now we're going to do the start doing the trend and we're going to do xtrend, xtest, trend, xtest, ytrend, and ytest. Okay, equals to the trend test split, and using the feature we just defined as a feature portion. Also, I'm going to using the diagnosis information as well. diagnosis information as my response or classification or the target. And then let's do the test size equals to 30%. So it's again, it's going to be a 30 and 70 split in that case. Okay. Okay. Need to rerun the import. So now after that, we are ready to using the KNN. So let me do this a little bit. Just mark using KNN. Okay. So here, first we're going to import the sklearn library of neighborhood, neighbors. We're going to import k neighbor, k neighbors classification, basically. Okay. Import that. Fire. Okay. Okay. Import the kneighbors classifier from the sklearn neighbors library. Define this model using a k nearest neighbor classifier, and that's as before. And how many neighbors we're going to have? Let's do equals to 1. Okay. So here we're going to have this, and let's move up a little bit for you. And then next what we're going to do is going to fit our model using train our model using the fit. So these step workflow is almost identical for different type of algorithm. First you import a class from the sklearn library, and then build the model and fit the model and predict the model. So the next step will be the fitting. So here KNN of fit. So this portion is fairly simple. I'm going to using the X trend information and the Y trend information. So as we said it in our as we mentioned in our previous presentation, the training portion of the k-nearest neighborhood algorithm is just to store all the training data. And the more time-consuming part is in the prediction. So here what we have is the prediction of the Y, and which is KNN predict. Okay, and using the X test. So here we have the reason. Second, this portion will give all the X tests as the input, which is the feature. We have 30 dimension of the feature as the input and calculate the nearest neighborhood based on our our calculation. So let's do that and see how it's done. It's relatively quick. So here what we're trying to do is we're going to see how our creation, our performance of this algorithm is. So without doing anything, we're using k equals to 1 to begin with. This n neighbors equals to 1 to begin with. So let's do that. Let's do from sklearn metrics. We did this before. Import classification report. Classification report, and let's do confusion matrix. confusion matrix. Okay, so import that. We're going to print out the confusion, both classification report and the confusion matrix. I'm going to print the confusion matrix first using white test and white predict. So print the white test and white predict. Okay, confusion matrix. So we see that we have total 96 classified correctly is one class, okay, and 66 classified as a benign, and 96 classified as malignant, and we have 4 and 5 are misclassified. So we don't know if this is a little bit better, and now we're trying to see, okay, how our classification report looks like. We're going to do classification report is the same thing using the white test and white predict. So it gives me a report. Actually, looks like it's not bad at all. It's about 95% or 94, 95% of the accuracy and the precision we have. F1 score also 95%. But anyway, we're going to, now we're doing, what do we do is we're going to choose a proper K. Proper K value, which is better. So choosing a proper K value, and for this particular case, let's do this, and how we're going to show you how to do the elbow test one more time. First, we're going to establish a matrix, okay, initiate a matrix called error rate, which recording all the error rate for each one of the K value. So here we're going to do for I in range of what? Let's do 1 to 20, for example. Okay, and we're going to perform the KNN again for each one of the K classifier, and we're going to do the N neighbor equals to I in this case. Okay, so and then we're going to do KNN, do the fed one more time. We basically just copy using the X trend and Y trend. Okay, and then predict using X trend and Y trend. Then we predict I equals to each one of the K and M prediction. Predict. Yes, I'm going to do the prediction using the X test. Set. Store the error rate. Okay. Append it into the NumPy average of prediction. Okay. A prediction when predict the I is not equals to the Y test value. Okay, so this is all there's to it. I don't need this. Okay, so done with the training. Okay, so this is all we have. Sorry, we need to redefine KNN equals to that, retrain. So everything is done. Now we're ready to plot the entire portion. I'm just going to copy and paste the plotting routine. It's basically plotting all the data into a one. Okay, I just need to rerun my routines right here. Start reinitialize error rate. So we see that actually in this data set, even the k equals to 3 to 6 will be giving us pretty good result already. So let's do one more time. We're going to first using k equals to 1 to see how that's going to go. So if k equals to 1, I will get about, already done that, benign is 96%, malignant is 93%, so accuracy, so that I have a 4 and 5 misclassified. So also, now we try to see if I have done the same thing, with equals to, for example, 6, 7, 6, 5, 6, let's do 6 in this case, and see how that's going to do. I'm changing that to 6, and rerun. So we got slightly better improvement than 6. So this is how, in this particular render number we generate, actually these two didn't have too much of a difference. And you can see one of them is about 96%, and this will give us 96%, so it's a 0.4 of error rate. So this is these two k value didn't have too much difference, because k equals to 1 already give us a very, very good classification accuracy, precision. So I will conclude this portion of the demo and tutorial and for the k nearest neighborhood.